Good morning. Welcome to the ongoing online course on Engineering or Architectural Graphics Part 2, where we are learning how to draw isometric projections. This is the third week of this course, and in the first 2 weeks of this course, we have already learned how to draw isometric projections for different types of two-dimensional objects and three-dimensional solids. Also, we have seen the isometric projections for sections of solids like the cut solids, for example frustum. But all these solids which we have been talking about are regular solids, and most of the time if you look at it in practice, whether it is engineering or architecture, you would not find pure solids occurring. So, we will always have combinations of these solids coming together. So, you will see that a building is made up of different shapes of cuboids, there are certain punctures and there are certain additions on top of that. Somewhere there is a cylinder, somewhere there is a cone being added or subtracted. So, that is how in practice the solids would appear. Now, when we are going ahead and developing the drawings for them, developing the isometric drawings for them for a better understanding, this is what we will get. So, we will first of course have to draw the orthographic projections of these combinations of solids, which is what we are knowing as combinations of solids, and then we will be drawing the isometric drawing or isometric projection of these solids from the orthographic projection. The process of drawing these combination solids remains exactly the same as we have understood so far. In fact, if you remember the last lecture of previous week where we were discussing about spheres and hemispheres, we have actually looked at the combinations of solids, because understanding sphere in isolation was very easy, how to draw that. But in combination it often becomes tricky, little difficult, and which is exactly what we are going to continue further. We will take a combination of different solids. Sometimes it is not that easy as it looks. It is easier in orthographic projection, it is easier to draw the orthographic projection, but slightly tricky. I would not say difficult, but if you know the process, you can very conveniently draw isometric projection or isometric drawing, but then it is slightly tricky and might take some little time, but then you have to have your fundamentals and basics in place. So, we will just see couple of examples here how to draw these combinations of solids. Okay. Now, if you look at this orthographic projection, this drawing here, it is like a box which has its lid on top of it. Now, how do we really draw it? So, I will start by drawing the bottom one and then I will take the lid on top of it. Okay. So, I am going to choose the color to tell you how it is going to be drawn. Now, forget about the lid totally. So, let us assume that this lid, this here does not exist and we are only looking at this. Okay. So, if I have to draw, this is like a cuboid, a box which we are going to draw. Okay. Now, initially when I say that I am taking a green colored line, which means that I am taking it in light. This is a light line as far as its darkness is concerned, but it is solid. Do not go by proportions. You will, when you draw, you will have to actually draw it in the same dimensions, same proportions as is given. Now, we can see that there is a dotted line all over, which implies that there is a thickness to this box. So, it is not solid, it is hollow, and this is what it is. And if we were to draw, if I were to extend this to the back, and if this was there and if it comes here, then it would somewhere be like this. So, we would also be seeing this line. This is what this bottom solid is, and inside at a certain height, and here you will actually be having, we are not going to draw it later on, but this is what it will look like. Okay. So, this is the bottom solid which we saw here, this is the bottom solid. Now, we have to draw the lid of it. So, there is one solid part of the lid in the original position, if it is like just upright. So, the reference is this point. So, we have this point as the reference, and now we can actually draw the lid of the box. So, this I am assuming this to be say 1 unit thick, the lid. So, again what I have drawn is the outer cuboid, but it again has certain thickness. So, what we have here is that we have certain thickness to it, right, and this one, if I have to draw exactly the same thing at the back, now it is not one complete unit, but it is lesser than that. So, we will have something like this coming, which is this dimension. So, this is what we will have, and we get the lid also in the original actual position. So, this is what we will see if we were to draw only this. Now, if we have to also draw how much back, how much inclination can this one take. So, what we have done here is that we already have a reference. So, this point remains the same. We have this rectangle A, B, C, D. Okay. So, this is not C, but C is here. This point remains here. So, if we were to draw it like this, then we would have to draw another rectangle, just like if you remember the original ones, which is how we have drawn. So, now once we have taken this rectangle A, B, C, D as the reference rectangle, we have to arrive at the other points, which is like this. So, we will be drawing only in dotted, because this is a position which it might take, but it is not actually the solid one. And exactly, so since this line which is going perpendicular is going to remain parallel to this, we can directly draw it. This is the reference point, and this line is going to be parallel to this line. You could actually draw another line which is parallel. So, the fundamentals remain the same. Parallel lines in the original object will appear as parallel in the isometric. So, we can actually use this to draw the rest of the lines, and we can also arrive at the inner dimensions, the thickness of the box, the lid of the box, and this is what we are going to get. So, if I were to darken only the solid part of the box, this is what we are going to see, what I am now drawing in the red. So, this is a very simple example of combination of solids, but why I took this example is because the solids are going to be the regular solids or distorted solids, but all we have to look at is their orthographic projection and just draw it out of that. You can take several examples to practice this. Take up any orthographic projection which is given. This is how you are going to see this. You can draw the dotted lines, you can draw them as light or dotted, whichever way suits you, but this is what we are going to see as the final solid. Let us take few more examples here. Now, this is a simple stool. Okay. There is no circle, it is all square, but the legs are slightly inclined inside towards the top. So, I will start drawing this one from the top, or I would rather take the squares first. Okay. So, when we do that, I am starting to draw from the top. Now, I am just assuming dimensions. You will have to take the exact ones, as I always say. Okay. So, there is certain thickness to it. This is what the top is. Okay. So, this is what we have drawn here. Now, the legs in the top, or we could also draw the square in the bottom. this is the central axis. So, if you look at this, the top one, this is where the center of the top square is, and you can take it down. This was 300. I am just assuming here that this is same 300 what it was in the top. So, taking it here, rather if I take it here, so I would get an exact square what we have in the top. Okay. I am just assuming that the top square and the bottom one where the legs of the stool are, it is just the same. Now, what we have here is that we have these squares. If we look at it from the top, we have these square legs. Okay. There are 4 legs of 40 by 40. Okay. So, where are they going to come? So, they are going to come here. So, we will draw squares at each of the corners 40 by 40. So, you can measure and you can actually make the squares. So, we know where the legs of the stool in the bottom are. So, these are the 4 squares which are here. Okay. This is what we have already drawn. Now, we have to know where the legs of these in the top are. Okay. That is what we are going to draw. So, this is a square of 250. Now, in this square which is here, exactly this square, we will draw a square which is of 250, which here we have taken it to be 300. So, the 250 will be 1/4 less than this. So, approximately here. So, we will draw a smaller square which will be somewhere here. So, this is the square that we are talking about. I am just darkening the points. Okay. Now, the square of these legs, it remains the same. It does not truncate to the bottom. So, what we have to identify or mark is 40 by 40 squares for the legs in the corner of this diminished square, which is say 250. Okay. Now, if you look at this, we have the legs, the square of the legs, the base of the legs in the top square and in the bottom square, and we can join it anytime. We will rather join it. So, go one by one. If I have to join this, okay. So, this is what we are going to do. So, it is going to be just at the back. Look at this, how it is coming. You have to be just careful about what you are joining, and if you have, the more you practice, the clearer your idea will be that how is it going to be seen. Now, we have drawn the legs. Now, what we have is we have these horizontal connectors. Okay. So, this is what we are going to draw. Now, if you look at this, this is going to be slightly inclined because this is what this plane is going to be. Now, this is at a height of 65. So, at a height of 65, now where will you measure the height of 65? We will measure the height of 65 here, or we could also measure the height of 65 here. Okay, but it does not make any sense, or it does not make any difference. So, I could take it like this. I can draw another square at 65. Now, where this square exactly will cut, this is what you have to realize, because if I am to draw a square here, okay, now look at this clearly. So, if I have to draw this square here, now here the plan is missing, but if we were to see the plan, so what will happen that this, the bottom of this piece, this wooden piece will actually be on this square, but it will be slightly inside. So, we will actually see that where that exactly comes, right, because the legs are slanting, we would not really know that where this is. So, if you see, it is going to come inside. So, this point will be arrived if we actually get this. So, if you join this properly, you will see that this is the diminished point, and we can actually draw where this leg is going to come, but this leg is this cross section, right, it is not this piece. So, what we need to know is where this piece is. So, I can actually draw this piece here, this is in dotted, and then just taking the parallel lines we can join it. We will have to do the same thing here. We will have to arrive at the leg, and then we will have to come at the portion in the leg which we are looking at, and then join it. This is how we will be arriving at the horizontal portions, these ones. So, we can join. Just remember that the parallel remains parallel. Okay? So, that is what we are going to see. The dotted lines, the solid lines, how they are going to come is what we are going to be seeing here. Now, if I blow up this one, this portion, because it is becoming slightly messed up here. So, if this was what we were seeing, this is the leg, I am just enlarging it slightly. Okay. This was the horizontal portion. Okay. Half of it is half the thickness of the leg is the thickness of this part. Okay. This is what we see. This is what we were seeing getting as the leg here. And you can actually see that it extends slightly. So, if I have to darken this part, I am just blowing up this detail. So, what this leg will be seen as is this. Look at the red ones. This is going to be dotted behind it, right? That is how it is. This is solid because it is coming in the front. This is again dotted. This is how you will actually see this portion and all others. So, for this part also you will see that if it comes and meets this, and then we will see this horizontal portion going out, and somewhere at the end we will actually be seeing this portion coming like this. So, this is how this portion is going to look like. Exactly the same thing will happen in the top, but a large part of it is going to be hidden underneath this square part, because this is the top part. So, when you draw, you must try to draw all the dotted lines in place. Okay. So, if I do not draw any dotted line, this is probably what we will be seeing, only the solids part, and this will actually be tucked in beneath the top square. So, this is how you can actually draw. All we have to do is ascertain if it is going inside, then we have to see that this distance, this offset is always seen. If this is where we were drawing this, where will this come is again on an incline. This is not a straight line, this is an inclined line, which is going to be parallel to this leg, which is what we saw here. So, it is parallel to this leg, but not perpendicular, right. So, that is what we have to have a clarity on, and if you keep these things in mind, you can possibly draw any combinations of solids. Let us look at couple of more examples. You must try doing these examples, solving these examples at home using the stationery on paper and using stationery by hand, not like what I am doing on screen. You have to learn to draw it very clearly. Okay, so here this is again a stool, very simple, not as complicated as the previous one, just that there is a circular plate on the top and there are 4 legs in the bottom. How do you exactly determine that where this is? Okay. Now, to determine that, what we will do, we will actually arrive at some common point. Now, what is that common point going to be? It is the center of the circle. Okay. Now, if I have to draw this circle from keeping the axis the same, we can do that. We can make another square here, and we will have another square which will be enclosing these 4 squares. So, we will basically be drawing 3 squares from the same axis. So, I am just marking the axis. So, if we look at this, this is the bottom point of the axis and this is the top point of the axis. Okay. So, say O, O dash. I will first draw this O, O dash. So, this is the axis that we are taking. Okay. O, O dash. Now, we will draw the top 2 circles first. Okay. So, what we have, say approximately this. Is the top circle. So, this is how the top circular plate is going to come, and then right beneath it. So, all we could do is, we know where the second surface of the same circular plate is going to come. This is a cylinder. We can draw another one, or you could just make it parallel to this one. So, what we have is that we will have another one which is going to be drawn parallel. Okay. So, this is the top one. Now, in the bottom one, so we have to have another square here. From this, suppose we have a square which is approximately this much, right. So, this is the square that we are talking about, and the corners of this square is where your legs are going to come, legs of the stool. So, I marked it in the top, this is the top one, and exactly in the bottom here we will have the same one marked. This is what it is. And marked the legs in the bottom square also. Now, all we have to do is join them. So, if we join this, I am joining only the visible portion of it. Okay. You can extend it, this is the dotted portion. So, we can just finalize this one, this is the circular plate of the stool. This is the visible portion of the legs. So, all we had to do was exactly ascertain where the legs are going to be placed, and then just draw the sections and then put them all together. This is the stool with straight legs and a circular top. Okay. Now, this is a nut, if as you can see. So, there is a hollow circle at the top, circular cylinder, and in the bottom you can see that this is a hexagon. Okay. And then towards the top, this flat surface, which is this flat surface, has a slight curve. So, what we are going to draw here is, we are going to first draw the hexagon. We know how do we draw hexagons? So, very simply we have drawn the hexagon, this is for the top one. Okay. You can do the same thing for the bottom one, or we could just take the heights of it, draw parallel lines, Okay. Now, what we will do, in the top we know that there is a circle which is going to be enclosed in this. So, there is going to be a circle enclosed in. Now, I am directly drawing it. We will actually first take the center, draw the square and then arrive at this. Okay. So, this is what we will do. So, arriving at this circle and then taking the same axis, the center of it, arriving at the inner circle also. Outer one, all that we have drawn. Now, one thing which we have to draw is these curves. Okay. Now, we have been given the radius of this. So, one way to do is that for every face we first identify that where the radius is going to be and draw the entire surface and then do it, or because it is not a very big part of the curve, what we can do is we can see, we can measure how much this depression is going to be, whatever it is, and then at this depression everywhere this is the point where the curve is going to touch the edge, right, and center of this is where it is going to merge this. Now, what we have is we have to merge the 3 points. So, you can actually use the French curves to join these 3 points, and similarly it will be at the back which will not be visible. So, this is slightly depressed here. So, this is how you are going to see this, again depressed here and like this. That is how we will be drawing this. So, what we will actually see, I will draw the front part of this nut, is like this. So, this is where it was going to come. And like this. You can ascertain that there will not be actually anything which will be visible inside. So, this is what it is. If you draw the circle of this one, this is the inner circle, you would probably see that we are not going to see anything in the bottom. So, we are not drawing it, but this is how we can actually draw these curved surfaces as well, and this is what we are going to see when we have been given the orthographic projections of a part of the machine like this. Okay. This is another one very similar. So, you have a square shaft, okay, a square base prism as we can say. So, this is what we are going to see here. I am directly drawing, very simple. So, this will be the shaft, right, which is this. Now, this square shaft is going and it is joining with this circle which is what you are seeing here. Okay. So, we have a circle. So, you have to identify, say, the base of it, and then make the circle here. So, we do it again same way. This is the circle that we are seeing here, right, in the bottom. Then we also have a square part which is here. So, this is the square part which is what we are seeing here. Okay. In fact, this circle was actually coming here because we were seeing it from the other side. And this is where, so all now what we have here is again a curved, a slightly curved part which is depressed here. You join these, and then the square part of it which is coming here but slightly depressed again, like this, slightly depressed here, which is this, join it straight and join it here in the bottom. This is what you are going to be seeing when we are seeing it from this side. The isometric is being drawn from this side, and this is the side view when it was seen from this. So, what we saw was this square, which is this, the edges, fixed edges, the circular part, which is actually taking a shape like this when drawn and cut, and the circle in the top, which is what we are seeing here like this. The square of the bottom shaft, and then there is a square of the circle of this shaft, which it is. So, what we will actually see is this. This is how it is joining this one. So, I will just erase the parts, this one, this circle. This is what you will probably see when you draw the isometric of this particular part. So, all we have to do, all I am doing repeatedly is I am seeing what is it in orthographic projection, drawing it exactly where it has to come. You could start from this side, or wherever you feel comfortable with, and then put together all the parts, all the lines that are seen here. Fundamentals remain the same. Parallel lines will appear as parallel. For the spherical parts and circle, we have to identify the center first and then draw it around it. So, this is how you will draw combinations of solids. I will close the lecture here today, but in the next lecture we are going to be seeing how, if two cylinders are coming together. If you remember, we did that as part of the orthographic projection, where two cylinders were intersecting, or a cylinder was intersecting with a cone. How do you arrive at the intersecting surfaces? How do you put all of them together in isometric? This is what we are going to be doing in the upcoming lectures. So, thank you very much for joining me today. See you again in tomorrow's lecture. Thank you. Bye-bye.